Hello and welcome to Noel's Retro Lab. I'm excited to show you today's computer, the ZX Spectrum 128K Toastrack Investronica Spanish edition. This is a computer we saw a few weeks ago, but this one comes with a box and everything. I have no idea what's inside and it's supposed to be untested, so let's open it up and find out, and let's do whatever we need to do to get it working. Let's carefully open it up and see what we find out. It's in really good shape. And yeah, there it is. It's actually quite a bit dirty. So that's good. I mean, that means that it had some use. It wasn't just sitting unused in the box. Okay, let's put that one over here. Of course, we have the numeric keypad. We have the charger, the video cable. Oh, yeah, this is a really good example. Look how the cable ate into the box right there. This happens a lot with old cables. I think it's the coating in the cable reacts with the material of the box and it just eats into it, kind of melts it. This is a double joystick expansion. I don't think this came in the box, but okay, that's nice. It's a nice addition. We have this cassette. So unfortunately the manuals are missing. There should be two manuals. I think there's like another tape or so. What's this? Oh, this is some kind of a repair receipt. We'll look at it later. All in all, this looks great. Repair receipts are really interesting because it tells you, well, clearly there was a problem in the computer and supposedly it was fixed. It says here what happened. So this is obviously from a Spanish site. Doesn't really tell us much, but then supposedly they put a new Z80 and then 4 of something that I don't recognize. I honestly don't know what this is. This doesn't ring a bell as any particular integrated circuit from the Spectrum. I don't know if it's a diode that I'm not familiar with, but what would be 4 of that? It was pretty cheap, 93. Oh no, 300. No, 93. 93 pesetas each. Well, that's like a tenth of the cost of the Z80. And then this is the amount of money they charge for actually doing the repair, which is way more than the cost of the pieces, but that's pretty normal as well. So, okay, so at least we've been warned that the Z80 had a problem at some point and supposedly was replaced. So I'm curious whether it's going to look any different when we look at it. I don't remember if it comes socketed or not, the Z80 in this particular Spectrum. Let's open it up and have a look at it actually before we even try it out. Okay, so yeah, clearly we see that the seal was broken. So as we suspected, somebody was here before. Okay, let's open it up and see what's going on. I carefully remove the keyboard connectors. Wow, the first thing I noticed is that the Z80 is not socketed. That's pretty surprising. I mean, I don't know. Honestly, I don't know what they did back in the 80s in official repair shops. I would imagine they would socket it, but maybe it was cheaper not to do that. Everything else looks pretty good. Wow, what is that? That doesn't seem like a normal connection. I don't remember that from other times, even though I know there's some weird setup. Well, this is like a diode in series with a resistance. But yeah, those are probably normal. I remember some things like this from the other ZX Spectrum 128K that we opened a few months ago. Let's look at the other side of the main board because we'll see exactly if really this was replaced, and by looking at the soldering, maybe we'll be able to tell what other 4 things were changed. So right off the bat, we see that the Z80 was definitely replaced, and they didn't even do a very good job, to be honest. They didn't clean up the flux. But interestingly, the integrated circuit next to it also looks like it was exchanged. So that's the ZX8401. which is some of the logic that before was in the main board as discrete 74XX logic, and it was combined into here. So yeah, I mean, it really looks like they replaced that, and the soldering looks about the same. So it looks like they were replaced at the same time. So I think that what we should do right now is power it up and see if it's working. And as you may remember from other videos, whenever possible, I like to try a computer for the first time with a bench power supply, because we can control the amount of current that it puts out. So in this case, we're going to be putting 9 volts, which is what the Spectrum needs, and it's reverse polarity from the normal. So it's center negative. That's why I have positive and negative switched in here. And I'm going to limit it to 1.2 amps. Otherwise, if we turn it on and it's a 3 amp power supply and we have a huge short, we'll just really destroy whatever is there or melt it or whatever. So, and this gives us a good idea of also what's going on. If we get 0 current, then it's almost like the switch is not working. Well, there isn't a switch, but like it's doing absolutely nothing. Or if we see very low current, or if we see very high current, then it's probably a short. So if we turn this on, it should just come on. So, oh, that's 0 amps. Why do we have 0 amps? Oh, because I haven't plugged in the voltage transformer. That's exactly why. This is why it's very useful. I'm actually leaving this in because it shows what a useful tool this is. Okay, let's hook it up correctly. Okay, we're back, and now we are hooked up to the voltage regulator. And so now we should really see some current draw, and hopefully we'll see something come up on the screen. All right, current draw, that's a little on the high side. And on the screen, yeah, we get some garbled square lines. That's very typical of the Spectrum. This is definitely a little on the high side. So I'm guessing there is a small short somewhere where it's hard to tell right now. Unlike the Commodore 64, the Spectrum is pretty easy that it starts displaying things on the screen even when lots of things are failing. So since we're getting some video, the first thing that we're going to do is turn it on with the ROM cartridge with the Diagnostics. And maybe it will simply tell us that it's a bad RAM. Okay, here it is. You've seen it before in some of the other ZX Spectrum videos. So I need to press this button while we turn it on. And we get nothing. We don't get the menu. We don't get the beeping either. Okay, that tells us it's something relatively major. It's not just a shorted RAM chip. It could be that, but there's got to be something else. My guess it's either Z80, the one they supposedly repaired. It's definitely another ROM because we're bypassing the ROM completely. I don't think it's this. If this chip was failing, I mean, unless it's destroying the bus, it will usually show as like all the memory banks are failing. It's very possible that it could be the ULA as well. So let's check it out with the oscilloscope and see if we can narrow things down. Okay, so let's check some of the signals, and actually we'll check voltages at the same time since I kind of skipped over that, mostly because I saw the current draw on the bench power supply be pretty reasonable. But yeah, let's make sure that the Z80 has 5 volts in pin 11. There you go, that's very close to that. First things, let's check for clock. Let's see that we're getting a clock. I suspect we are, otherwise we'll see a lot less current draw. Well, that's a bad start. Do we have any activity whatsoever? Nothing. Wow, it's dead. And it's getting this. So I'm checking address bus, random bits on the address bus, and they're not even low or high. They're just sitting there. So I was checking the circuit diagram, and the clock signal that arrives to the Z80 at pin 6 comes from the ULA. So it's generated in the ULA in pin 39, I believe. And then it gets amplified through a transistor and sent over to the CPU. So it could be the transistor. This is 39. And we have something. I put an AC so we can zoom in more. So yeah, there is something there. It looks very small. That's about 200 millivolts amplitude total. I think the clock signal generated by the ULA is definitely stronger than that. There's more amplitude to it. So the clock signal comes from the crystal oscillator as usual. Then it goes through an integrated circuit, I think it's that one. And it should generate a 17.7 megahertz signal that gets fed into pin 1 of the ULA. So we should see it right here. That looks pretty good. Yeah, that's perfect. Yep, 17.7 megahertz exactly. So the input clock signal looks good, but the output clock signal looks really bad. So I suppose it could be a problem with the ULA. So it could be the ULA, and it's socketed, so it's really easy to test. And I do happen to have a working ZX Spectrum Plus 2 Gray, which uses the same kind of ULA. So let's go ahead and swap them out and see if they work. Here's the new ULA. And that's the beautiful thing about sockets, how easy it is to pop them in. We have the new ULA in, so let's turn it on and see if we get the basic prompt. There you go. So that was it. That was just the ULA. So now let's go back and just double check that clock signal going into the CPU clearly has to be present. Yeah, there you go. That's very nice and healthy, 3.5 megahertz. And then let's look at what the ULA was outputting, just so we know it next time. Here. Okay, that's more like it. So it's not as large as amplified when it gets sent to the CPU, but it's definitely not the wobbly 200 millivolts that we were seeing earlier. Here, it looks like it has at least 1 volt of amplitude. So it looks like that was it. It's just the ULA that was faulty and everything else seems to be fine. And now let's try the diagnostics with the working ULA just to make sure that all the memory is good and everything. Oh. Interesting. We are getting nothing with the diagnostics. What about if we just try to run the ROM that is here? Oh, so really, us testing this earlier didn't do much good. I suspect what's happening, I actually noticed that earlier, and I forgot to mention it. It looks like there's some paint in there. I know the ROMs in here are working, or they were working a few days ago, so I'm going to assume they're still working. Chances are this is not making contact correctly. I don't know what that is. It looks like some kind of red ink. So I'm going to clean that well and try again the Diagnostics program. That is really stuck in there. And there's more in the back. I wonder if I should try alcohol first to try to dissolve it instead of trying to wear it off with a sandpaper or this abrasive thing. Yeah, let's try that. It's not really picking it up. What is this? If this was working, this should be turning red, and it's not. So I don't think the alcohol is dissolving this at all. Okay, let's try with something stronger. Here's some nail polish remover. Now this is acetone free, so I'm not sure it's gonna work as well, but that's all I had in the house. Yeah, there we go. It's totally turning red. Yeah, much better. So this was some pretty strong paint enamel that they put here. Okay, we'll clean this with alcohol in a second. I'm going to do the other side. Okay, now let's clean that with some isopropyl alcohol. Okay, perfect. So I bet now our Diagnostics program works without a hitch. Okay, press the button, turn it on. There we go. So that was it. It was just the edge connector was dirty. It happens a lot, not usually with that kind of paint, but any kind of corrosion will often make external ROMs like that not work. So perfect. It looks like all the tests are passing. So let's say this is working correctly now. Okay, we got the ZX Spectrum working. So now it's time to give it a good scrub and leave it as good as new. So on to the cleaning, and the board is pretty clean. The case is a little bit dirty there, but I think we can just remove the board and give it a good wash, and that's pretty good. The keyboard, however, it's actually pretty dirty. So sometimes these keyboards, you can just brush them and that's good enough, but that's a lot of dirt in there. So we're gonna have to remove the keys. I think I saw, like, if you look in there, you see that it's filthy underneath. So we're definitely gonna have to pop all the keys and clean them separately. But I think it can end up looking really, really good. Now we remove all the keys. And the keyboard membrane layers. And now wait for it. Oops. Yeah, that's what you're not supposed to do. Okay, time to clean all the keys. I gave the cases a good scrubbing with hot water and soap, but I wanted to show you that it's just not good enough. I mean, look at all the dirt in those cracks. Clearly they did not design cases in the 80s thinking of cleaning them up. But yeah, this is all pretty filthy. So I'm going to use the next line of defense for this, which is a window cleaner and a toothbrush. So while I was cleaning this, the serial number came off. And it's not a big deal, but I just like to glue it back together before we do anything else here. It looks like it came from there. So I'm just going to put a little bit of super glue and put it back in place. All right, that looks pretty good. All the little grooves are clean. They don't have dirt in them anymore. But there's one more step that I like to do before putting everything back together, and that's to put some car dashboard protectant, like this. That helps, first of all, give it a nice look to it. It's a little dull right now, so it will make it look a little shinier and newer, but it will also protect it down the line from aging, or not yellowing in this case, but it will help with yellowing in other computers. It will just protect the plastic and restore some of the shininess that it had. So we just apply some of that cream and spread it with a paper towel. Okay, now we let it sit there for a few minutes while we do the other half. After a few minutes, all we need to do now is wipe down the excess cream left still on the case, like this. And now we can use a clean dry rag and just scrub it down really well. One trick in places like this that have a lot of little grooves and places for that cream to get stuck is to use a toothbrush, same one that we used before, and just spread it out a little bit, and then pass the rag and maybe do it again. And that just smears all that cream around. And there you go. It's very, very nice now. That looks great now. Okay, we still have a couple things to check, but we're pretty much done. So the numeric keypad, I was assuming it was going to be brand new, but surprisingly, it shows some signs of usage, just like the keyboard. So that's pretty cool. I didn't think many people use these, but it certainly got some use. So I'll definitely do some scrubbing. Maybe I won't even have to take the keys off from here. And the other very important thing to check is the power supply. Usually when these power supplies fail, they just don't give out as much current, but it's still good to check that it's given voltage within the reasonable range, which this Spectrum takes 9 volts center negative. But these old power supplies usually report significantly higher voltage when they're not connected to any load. So it's not unusual to see them as high as 12, 13, 14, 15. Okay, well, there's a light in here. It's not turning on. Oh, this model has a switch. I forgot about that. Okay, light comes on. And let's see what kind of voltage we're getting over here. Yeah, 14. Yep, that's normal. Okay, so that looks good. So let's go ahead and test everything with the computer and make sure everything works well. Let's run some tests. Let's start testing the numeric keypad. So for that, we need to enter the edit mode. And yeah, there we go. Okay, that works well. The rest of the keyboard also works well, which is a good thing because I didn't test the membrane earlier, but it looked really good. It looked nice and fresh, so I'm not surprised that it works well. Okay, let's load up some games. Let's load one of my favorites, like Cybernoid. Well, it looks like it plays great, and it looks like practically brand new, so I think that was a very successful restoration. So there you go, we have successfully restored and repaired the ZX Spectrum 128K. I hope that was useful to you and maybe gave you some ideas on how to go about repairing and restoring your own ZX Spectrums. If you liked the video, please give it a thumbs up and subscribe to the channel. Until next video, see you then.